Here we have a problem on derivative. Okay, let's go the information. Given that f of x equals to 3x, g of x equals to 2x, and y equals to f of g of x, find dy over dx. Okay, so there is a function given over here that is y equals to f of g of x. Actually, this is a composition of two functions f and g, and so we have to find dy over dx. That is, we have to find the derivative of this function with respect to x. Okay, now let me do it. So when I find derivative of this y with respect to x, it will become dy over dx. Okay, here we have a composition of two functions on the right side. So whenever I find derivative of composition of two functions, I have to get derivative of the first function, that is f over here. So when I do so, I'm getting f prime of g of x. By chain rule, I have to do further derivative for the function that we have inside the square bracket over here. So when I get derivative of this function g of x, I'm getting g prime of x. Okay, now to get the result for dy over dx, what I need to do is I have to multiply the product of the two derivatives over here. Okay, I don't have any trouble to get g prime of x because we know that g of x equals to 2x. So if I find derivative on both sides, I'll be getting g prime of x. But I have trouble to find the f prime of g of x, because when I look at the stuff over here, when I look at the function f of x, inside the parenthesis, I just have single variable over here, just x. But here, instead of single variable, we have a function over here. That's a trouble. So if I have single variable over here, I can find the derivative of f easily. So for that, what I'm going to do is I'm going to assign a new variable u for this complete function g of x. So let u equals to g of x. Then dy over dx equals to f prime of, instead of this g of x, now I can plug in u. So then I'm getting f prime of u times g prime of x. Okay, now let's get the result for f prime of u. That is, I have to find the derivative of f of u. Okay, already I know that f of x equals to 3x. That's given in the question itself. Okay, now in this function, I'm going to replace this x by u, because here we have u. So let me replace this x by u. On the right side also, I have to replace the x by u, then I'm getting 3u. Okay, now I have f of u equals to 3u, but I need f prime of u. That means I have to get derivative of this f of u. So if I find derivative of this f of u, I'll be getting f prime of u. And also it's a function of u. So here the derivative we do with respect to the variable u. So when I find derivative of this f of u, with respect to u, I'm getting f prime of u. On the right side, so u is the variable, it is multiplied by the constant. When I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is. When I find the derivative of this variable u with respect to u, it will become 1. So 3 times 1 will become 3. So now I got f prime of u. Okay, now my aim is to get g prime of x. So for that, I consider the function g of x that's given in the question itself. That is g of x equals to, we have 2x. Okay, to get g prime of x, what I need to do is I have to find the derivative of this g of x. When I find the derivative of this g of x, so it will become g prime of x. And also, it's a function of the variable x. So the derivative we do over here with respect to x. Okay, so when I find the derivative of this g of x with respect to x, it becomes g prime of x. And here the variable is multiplied by the constant. So when I find derivative, I have to keep the constant as it is. When I find the derivative of this variable x with respect to x, it will become 1. So g prime of x equals to 2 times 1 is 2. So now I got f prime of u, that is 3, and g prime of x, that is 2. So now we can plug in the results over here. So dy over dx equals to, so for f prime of u, we can plug in 3. And for g prime of x, we can plug in 2. So 3 times 2 is equal to 6. Now I got the result for dy over dx. So that is 6.